Hello everyone. In the last class we have discussed about the vector multiplication. We will go through very important concept known as the gradient. So what is gradient? Actually gradient of a scalar field indicates the direction of maximum change of that scalar field. So let's try to understand through this example. This shows the three-dimensional Cartesian coordinate system, and at the origin there is a heat source. Right now you are moving along the y direction and holding a thermometer with you. You are moving so far that there is a possibility of change in temperature. Imagine for each 1 meter traveling there is a 10 degrees centigrade temperature fall. That is, rate of change of temperature with respect to distance is 10 degrees centigrade. For example, let us consider at the origin there is a temperature of 200 degree centigrade, and at the 1 meter distance from the origin the temperature becomes 190 degrees centigrade. Now consider the second situation. Here you are moving along the x direction, and here also temperature decreases when you moving along the x-axis. What do you think? The rate of change of temperature will be same for the two cases. That means previously you have seen the rate of change of temperature is 10 degrees centigrade, and here what is your idea? What do you think? Here also there will be a 10 degrees centigrade temperature change. The rate of change of temperature may be same or may not be. For our present case, let us consider the rate of change is 20 degree centigrade. That is, for 1 meter traveling along the x-axis, there is a decrease in temperature of 20 degree centigrade. Now, let's take the third situation. Here, you are moving along the upward direction and consider the rate of fall of temperature is 5 degrees centigrade. Okay. Similarly, if you move along any arbitrary direction, let's say along this direction or that direction or that direction, there is a rate of change of temperature, and this change may be different for different directions. So what we observed? We have seen that although temperature is a scalar quantity, when we consider the rate of change in temperature, there is some directional sense. Now, if I ask you this question, that how fast does temperature vary? Can you give the proper answer? Obviously not, because in different direction this temperature variation is different. So actually there are infinite number of answers. So how to find the answer of your queries? We can manage it through partial differentiation. I think you all are familiar with the partial differentiation. If not, then write in the comment box. I will make separate video on partial differentiation. Hence try to find out the answer of our question, that how fast does temperature vary. As we know, the temperature is a scalar quantity and it is a function of x, y and z in space, since at each point in space we get a definite value of temperature. That means if you are holding a thermometer and if you move through this space, at each and every point your thermometer show one value. So we can write the temperature, which is a function of x, y and z. First, we will find the change in temperature along an arbitrary direction. So right now we are not considering only the x-axis or y-axis or z-axis. Instead of this axis, we are considering an arbitrary direction, let's say along this direction, and we want to find out what is the change in temperature. Not the change in temperature, but infinitesimal change in temperature. That means we want to find out dt in this arbitrary direction. So first, what we will do? We will do the partial differentiation of this temperature. That means dt, that is the infinitesimal change in temperature, which is expressed as del t del x when y and z is constant, dx, plus del t del y z x constant dy, and del t del z when x y constant dz. What is del t del x? This is the change of temperature with respect to x when you moving a very infinitesimal displacement dx along the x-axis, and this is the partial differentiation of temperature. Then we will find the direction along which this change is maximum. So first we have calculate the change in temperature dt in an arbitrary direction, and next we will find the direction along which this change is maximum. That is, we want to know dt max, and we want to find out the direction along which this dt will be maximum. But still dt is a scalar quantity, right? Because dt is nothing but the change in temperature. So how to generate the directional sense to find the direction of maximum change? So what we have seen? We have seen that dt is a scalar quantity, but we want to find out the direction, some direction along which this dt will be maximum. But dt is a scalar quantity, so how to add this directional sense with dt? This is our query. So let's see it, how to do that one. So we can write this dt in this form, that is dt is equal to del t del x, x cap, plus del t del y, y cap, plus del t del z, z cap, and dot product with dx x cap plus dy y cap plus dz z cap. So if we do dot product, then we get the previous line. That means this line and this line is same, as we have seen in our last lecture about the algebraical form of dot product. Now we write dt in this manner. So let's see it, how to write dt. dt is equal to some symbol associated with temperature dot dr vector, right? I will explain each and every term one by one. So how do we get that dx x cap, dy y cap and dz z cap as dr vector? For that, see this right side picture. R can be written as, let's say P is a point in this Euclidean space, and OP is an arbitrary vector, position vector R. So R can be written in this form, that is R vector is equal to x x cap plus y y cap plus z z cap. Then dr is equal to dx x cap plus dy y cap plus dz z cap. What is dr? Dr vector is the infinitesimal displacement along an arbitrary direction r. And what is this symbol mean? That means that is some symbol which is associated with the temperature. This is like the delta, but it is not the delta. It is a differential operator which is a vector quantity, and this is expressed as del del x x cap plus del del y y cap plus del del z z cap. And this differential operator is known as nabla. When nabla is associated with any scalar field, for this example the scalar field is temperature, then the total symbol, that means nabla and temperature T, this total term is known as the gradient of the temperature. When nabla is associated with any scalar field like temperature, then this whole term is known as the gradient of the temperature. What is the physical meaning of the gradient of any scalar field? We will discuss later on. So what we get? We get that dt is equal to gradient of t dot dr. Now we find the maximum change in dt. So what we have found out? Till now we get that there is a change in temperature dt. Our next task is to find the dt maximum, and then we will find in which direction this change in temperature is maximum. So for that we will find the maximum change in dt, and to find that we write the geometrical form of the above expression. That means we will write the geometrical form of this dot product. So what is the geometrical form? That is magnitude of gradient of t into magnitude of dr vector and cos theta, where theta is the angle between gradient of t and dr vector. So when this dt will be maximum, because we want to find out this one, so when this dt will be maximum, as you can see, when cos theta is 1, so the maximum value of cos theta is 1, and if cos theta is 1, then dt will be maximum. But when cos theta will be 1, when theta is equal to 0 degree, then cos theta is maximum. So we found out that dt maximum, that is dt max, is equal to magnitude of gradient of t into magnitude of dr. So next task, to find out the direction along which dt is maximum. So let's try to understand this phenomenon geometrically. Let in space we move an infinitesimal displaced distance dr along arbitrary direction. So first of all, you are here, and from that point you can move in any direction, but the distance of these directions are dr. But we don't know the direction of gradient of t. So we are standing here and we can move along this direction or that direction or this direction, but we don't know in which direction this gradient of t acts. So now after many trials, that means if we start from here, we move along this direction or that direction or this direction, after such many trials we will move in such a direction along which dt is maximum. So what is our aim? We want to find out that dt maximum and the direction of this dt maximum. So we are using the trial and error method. That means we are first moving along this direction and measuring is dt is maximum along this direction? No. Then we start along this way, we move along this way, we move along this way, and we try to find out in which direction dt is maximum. And after so many such trials, we will find such direction along which dt is maximum. That is, right now I am moving along the same direction of gradient of t, because to make dt maximum, theta should be 0, and theta is the angle between gradient of t and dr vector. So when I will move along this gradient of t direction, then is only possibility to get dt maximum. So in other words, we can say that gradient of t is the direction along which there is a maximum change in temperature. So our aim is to find out dt maximum and in which direction this dt is maximum. So right now we found out that if we move along this gradient of t direction, then only there is a maximum change in temperature. So gradient of t indicates the direction of maximum change of this scalar field. So we may conclude that gradient of a scalar field points direction of maximum change of this scalar field. In space, we find gradient is different for different points. It will be more clear if we take some numerical problems. So I have written here that when theta is 0 degree, then dt is maximum, and theta is 0 degree only when dr and dr is along the gradient of t. That means gradient of t points the direction of the maximum change of temperature. So let's take some numerical problems to understand the gradient. So how to solve the numerical problem of gradient? So if we follow these 4 steps, then we can solve any gradient problem in Cartesian coordinate system. So first of all, write the expression of nabla, which is del del x x cap plus del del y y cap plus del del z z cap. Then write the given function t, and it will be given to you. And in the third point, calculate this gradient of t. And fourth point, find the gradient of t for the given point in the space. As we have discussed that gradient of any scalar field is point dependent. That means in space, in different point, the gradient of the same scalar field may be different. So this point is very important, that we can find the gradient of any scalar field for a particular point only. Now let's take one example. Here it is asked that the find of the gradient of the following function, that is t x y z, which is x square y cube and z to the power 4 at the point 1 1 and 1. So what is the physical meaning of this problem? That means we want to know along in which direction this scalar function has a maximum change. That means we want to find out the gradient of this scalar function. So let's see it how to solve this problem. So first step is write the expression for nabla, which is del del x x cap plus del del y y cap plus del del z z cap. In the second step, write the given function which is t xyz is x square y cube and z to the power 4. In the third step, calculate the gradient of t. That means just write down the expression for nabla and expression for given function. That means nabla, which is del del x x cap plus del del y y cap plus del del z z cap, and the given function x square y cube z to the power 4. Remember that don't use any dot or cross in between nabla and the given function. If you put this any symbol, then it will be meaningless. It will not show the gradient of this scalar function. Now we have to solve this differentiation. The next part is we have to operate these differentials separately on the given function. That means first del del x will operate on this whole function. This is del del x, x square y cube z to the power 4, x cap as it is. Then this del del y operates on the whole function, and at last del del z will operate on the same function. Here we have to evaluate the partial differentiation. That means del del x will only operate on the x term, where y and z term remains constant. Similarly, when del del y operates on this term, it will act only on the y term, x and z term remains constant. And when del del z operates on this term, del del z will only act on the z term, keeping x and y term constant. So let's see it. So gradient of t becomes when del del x operates on the x term, that is x square, that is del del x x square, it gives us 2x, where y cube and z to the power 4 remains constant. When del del y operates on y cube, that is del del y y cube, it gives us 3y square, and x square and z to the power 4 remains constant. Similarly, when del del z operates on the z to the power 4 term, that is del del z z to the power 4, it gives us 4z cube, and x and y terms remains constant. Now the last and the fourth step. Here in this question it is asked to find out the gradient at the point 1 1 1. That means if we draw the Cartesian coordinates, let's say it is the x-axis, y-axis and z-axis, and if this point is 1 1 and 1, we have to find out the gradient of this function at that point. That means if you are standing at that point, you want to know along in which direction this temperature or this function changes in the maximum sense. So what we have to do, we have to just substitute this 1 1 and 1 in place of x, y and z respectively. So let's see it. So if we put these values, that means in place of x we will use x is equal to 1, y equal to 1 and z equal to 1. So what we will get, we find this expression, and our result is 2x cap plus 3y cap plus 4z cap. So in this way we can solve any problem regarding this gradient in the Cartesian coordinate system. In the next class we will discuss about another phenomenon which is known as the divergence. So thank you for your kind attention.